Thanks, George, and good morning, good afternoon to everybody on the call today. As George kindly introduced me, my name is Helen Beal. I'm a DevOpsologist here at Range4, and today I'm delighted to be joined by Andreas Grabner, technology strategist at Dynatrace. So, hi, Andy.
Hi, Helen. Hi, I love your title, DevOpsologist, huh?
Thank you. It's what I do
It's
all
really cool.
day. So I'm going to start by giving us just some kind of background to DevOps. So this is a short history of DevOps slide that we've compiled over the years. It's nearly due another update as we're starting to near to 2017, but you'll see that DevOps started as a grassroots movement with a hashtag that Patrick Dubois, a Belgian, put on Twitter quite some time ago now. We're coming up to a 10-year anniversary. Always feels like about 5 in my head, so it's been a while. And as you'll see over the years, more and more events have happened. So DevOps days are very regularly happening all around the world. I know that some of the attendees today will have been at various DevOps days, either in Ghent or in London or elsewhere in the world. Around sort of 2010, sort of 2011, the big analysts, Gartner, started getting involved and started thinking about DevOps, really what it means. We saw the Phoenix Project, the seminal novel about DevOps, come through in 2013. We launched a game with that name that is licensed from the IT Revolution press people who published that book. And we've just seen at the start of last month in October the launch of the DevOps Handbook. So DevOps is here. It's becoming kind of more defined, if you like. So a few years ago, we were certainly having problems saying what it exactly was. And this is an acronym that we used a lot, almost like an elevator pitch. It originated from John Willis as CAMS, as an explanation of what the component parts of DevOps are. And for those of you that aren't familiar with the acronym, the C is for culture, the A is for automation, the M is for measurement, and the S is for sharing. And those of you that are listening carefully will be wondering why I missed out the L. And that's because the L came later. It was added by Jez Humble, then of ThoughtWorks, who was the writer of Continuous Delivery and also the Lean Enterprise. So these are 5 things we think about when we're doing DevOps. But for the purposes of today, we're going to be primarily focused on the M. So we have Andreas here from Dynatrace. So we're going to be talking about the DevOps loop, as we described, and specifically how measurement applies to the loop. So just again, harking back to the Phoenix Project, when we're talking about the foundations of DevOps and what it really is, those of you that have read the Phoenix Project will be familiar with the 3 ways, which are the underpinning principles of what we're trying to do when we do DevOps activities. So the first way is about increasing the flow between dev and ops, so across that value stream of getting innovation and change through to your customer or your user. The second way is about amplifying feedback loops between dev and ops, or actually between the customer and your business. So it's all about concertinaing or shrinking the amount of time it takes to understand what somebody needs and deliver it to them. And the third way is about experimentation and learning. So this is the ability to have a culture and an environment that is set up to allow people to have the time and the space to innovate. So they have safe systems and ways to fail smartly or safely, and they have the time. So they're not constantly firefighting. They're not constantly up against trying to tackle technical debt. They have the facility to be able to invent new things that they know their customers want because they've had the feedback from the second way, and deliver them fast because they've increased that flow in the first way. So just to recap, the first way is about flow, the second way is about feedback loops, and the third way is about experimentation and learning. So this is the DevOps loop that we're talking about closing today in today's webinar. So when I used to describe an SDLC in some kind of visualized diagram, I used to have lots of steps in a very linear sequential way. And that isn't really what we're trying to do with DevOps. With DevOps, as in the kind of the underpinning principles of Agile, what we're trying to do is do continuous iterative or incremental improvement. So we now represent the SDLC like this. So this is our DevOps loop. You could also call it a continuous release cycle. You could also call it a DevOps toolchain, although toolchain to me also is quite a linear description often. We have 5 component parts to our loop. So we call it IVA. You can see we've got ideation, integration, validation, operation, and realization. So ideation is the collection and inception of ideas. and the way that we manage and prioritize that, and our product backlog, how we refine all of that. Integration is where the build and the development, if you like, occurs, but we prefer the word integration because most of the organizations that we work with these days are less coding and more compiling or composing applications out of artifacts that they collect and retain in repositories like Artifactory and Nexus. The third part here is around validation, and actually validation and integration are very close together. So you'll all know about shifting left, you'll all know about testing early, you'll all know about building security in early, hopefully. So being able to know, for example, which of those artifacts your developer is about to put in your application might actually have a security vulnerability. The O in either is all about operations. So this is the point at which things are deployed into the run or the live or the production environments, and they start hitting the support desk or the maintenance cycles. And the realization is the bit that we're primarily going to focus on today. So this is the measurement piece. So the idea behind the DevOps loop is that you can measure from ideation to realization, or the aha to ka-ching moment. So this is giving you the facility to not only measure the traceability of the cost of a feature as it runs through either, but also being able to measure the value of that feature as it goes live and as it is being used by your customers, and measuring that using a metric that makes real business sense to you. So something that is normally revenue focused, or it could be, if you're an insurance company, for example, the amount of policy requests that are completed on a particular page. So we talk a lot about metrics that matter at Ranger 4. In the old days in DevOps, we used to talk about a set of metrics that were things like the volume of frequency of release, the volume of defects, the time taken to fix a defect, MTTR, particularly around application monitoring. We used to talk about MTTR, or the mean time to response or recover or repair, quite a lot. We used to talk about the number of outages and the length of time that outages happen for. As we've developed our DevOps methodologies as a market, we've started to learn that the importance of things like lean are really critical to what we do. So actually getting that outside-in customer view of everything we do is really essential, understanding what our organizational why is. So the metrics that really matter are the metrics that pertain to what we do as an organization, rather than just what our IT equipment is doing. So at this point, I'm going to pass Andy some control over my screen, and Andy's going to give us an overview of digital performance management, and then show us in quite some detail how Dynatrace helps us measure that value at the end of the DevOps loop. So give us the realization element of what we're trying to do.
Thanks, Helen, and thanks for trusting me with the remote control of your machine. That's part of the cultural aspect of DevOps, I would say, right? Trusting each other and then making sure that as a team we are actually working together and delivering value. So hopefully I can give you some insight, as you said. I like that you actually call it digital performance management, because the way around the Dynatrace place in the APM market, application performance management, I think it has evolved over the time to DPM, digital performance management, because why? We saw, and as you also said earlier, we're building new types of applications. Either we build them from scratch, or a lot of people are actually taking their existing apps, merging them together with some other components, services, building new front-end applications using new technology, and with that, delivering value to their end users. And this is actually what we try to do. So Dynatrace, what we are able to do is we are able to monitor your end users through the whole delivery pipeline of your software service. So when your users using a browser, a mobile application, mobile native, mobile hybrid, mobile web, whether you access content from third-party services that are out there, whether you're deploying content through a CDN, whether your software runs in the cloud, on-premise, on virtualization stacks, whether you already use containers or still run on bare metal, whether you run Java, .NET, PHP, or even on the mainframe. So we got you covered. What Dynatrace will be built is really giving you metrics end-to-end to figure out, did you build the right thing for the users? Are they happy with it? And in case there's a problem somewhere along the way, where is the problem in that value delivery chain? So we support full stack. We understand there's a lot of technologies out there that you've been using and that you will use in the future. Now, what we've also done, obviously, make this data available. We make it available in an easy way, whether it is through our web dashboards that you see here, where we automatically analyze data, as I said earlier, from the end users, from a service perspective, from your infrastructure perspective, and basically correlate everything together, and then can give you answers to questions like, hey, do we have a problem right now after we made a deployment? Are users impacted in a certain geographical location? Are they responding to a campaign in the right way, or do we have any problems? We have different ways of visualizing the data. I just want to give you one very interesting way of visualizing data, which is actually something we have introduced in our engineering teams. So when you walk into one of our Dynatrace offices, we are embracing DevOps. We have continuous integration, continuous delivery, and we actually make sure that the data that tells every stakeholder whether the code that they just pushed through the pipeline out to the customers actually had a positive or negative impact. And the best way to visualize that is with the two colors, green and red. We hook this pipeline, this radiator, I think that people call it a radiator, a data radiator, in the different sections of our organization. Development teams use it to see how far away the code change went into the Jenkins pipeline. Our marketing team uses it to figure out how well is their campaign going. The ops team is using it to figure out how the resources are doing on Docker, VMware, or EC2. So it's an interesting way to visualize data. Now, I'll give you some use cases how we use Dynatrace internally, but most of our customers use Dynatrace. The first feedback loop that you obviously want to have if you deploy change out into production, you want to know, is your system still available? So we're using synthetic monitoring. We provide synthetic monitoring to figure out, is your service, your application accessible from the different points in the world? And if you make a deployment and you make a mistake, whether you're reconfiguring and wrongly configuring a DNS entry, whether something bad happens, maybe to your third-party hoster, and availability drops to 0 in your target markets, that's obviously not good. So Dynatrace automatically detects that and alerts you. Another thing we do, we are aware that most of the software that is built these days is used by end users through different devices. So we capture every single end user, every single click along the way. We know who they are. That means we know where they're coming from, the geolocation, we know the type of device. We know the user experience, whether they have a good experience, a tolerating or frustrating experience. We are factoring in things like performance of every single step along the way. We also factor in errors. So if everything was perfectly fine, but at the end of the checkup process, they received a, sorry, something happened in the background, come back later, and that leads them to drop off. That's obviously a bad experience. We also look at data that we can capture from A/B testing environments. So these are some of the new concepts that people use, especially around DevOps and around the experimentation phase that Gene Kim has been talking about in his books. In the last way, in the third way, you're trying to experiment. You're coming up with a thesis, and then you are pushing out features to users, and then you see how they react. So we provide all of these insights, and with that, closing the feedback loop. Now, here's a great story. What you see on the top is the number of users on the system. Again, green, red, and orange. And you mentioned one of the metrics for depending on which software you're running could be the number of claims you process, the number of revenue you make. In this case, how many people sign up for a service. And what's interesting with this example is that the marketing team was pushing out email campaigns to get more people on the site. The marketing campaign can use these metrics to close the feedback loop and say, hey, does my marketing campaign actually work? Do I get more people on the website, and are they also signing up? So conversion rate goes up. If marketing continues following the trend, and like in this example on day 2, which was May 2nd, they saw an increase in unhappy users, meaning the more and more users they brought on their site, the unhappier they became because the system itself slowed down, which is obviously not good. So they went back to the engineering team and said, you know, let's fix something. We need to make this faster because otherwise our marketing campaign is not as efficient. Engineering team provided a fix, deployed it out through the deployment pipeline. Unfortunately, introduced the problem, which actually caused a spike in frustrated users, a drop in happy users, and a drop in conversion rate. With these feedback loops that you get within minutes of deployment, all of the stakeholders knew what the problem is. So it was a functional issue, a performance problem that lead to frustrated users. If you have an automated pipeline, if you have the first wave figured out, you can fortunately react very fast on that feedback and provide a fix. Okay, so really powerful metrics, how you can actually then combine marketing values, sales values with the engineering side. And another thing is when you run on scalable architecture that automatically scales up and down depending on load, or scaling up to make sure that you're meeting your SLAs. This is an example where on July 3rd, a new deployment was made, and unfortunately, a memory leak was introduced. Memory leaks are not a good thing from a technical perspective. They kind of get hidden away if you have an automatic scalable system running on AWS, Google Cloud, or Microsoft, or any other cloud provider. So if this is hidden away, it is bad, because if you don't see actually that through a memory leak you had memory increase but also CPU increase because of garbage collection kicks in, you may end up paying a lot of money at the end of the month for particular features to your infrastructure as a service provider. This is why for us it is very important that when we talk about performance, we're not only talking about response time and user experience, but also how efficient the application actually runs. And if you introduce a change that is making code less efficient, more resource consuming, you need to be aware of as fast as possible. Last example that I have here is it's very important to understand user behavior, so we can easily track user behavior, figuring out how are users using our system, where are they clicking to, are they consuming the content that we want, and how does the behavior change over time if they have a good experience with our app, or if the experience changes to moderate to frustrating. And this is a very powerful way of understanding the impact that you have on the end users, and with that you can close the feedback loop again and immediately make a correcting action and saying, hey, it seems with the last deployment everything became slower, and we immediately see the impact because people are not clicking on the content anymore that we want. So I believe this is very powerful of closing the feedback loop. It's kind of the second way that Kim has been writing about in his books. Now, where I think we as an industry have become really good in monitoring production and then being faster with figuring out what went wrong if something went wrong. I believe where we need to go, and this is really kind of bringing the DevOps best practices and the DevOps loops, the feedback loops, early in the life cycle and including everybody along the way. I think if we do it right, we can get from reactive production monitoring, firefighting, to becoming proactive if we really measure everything we do, every single step along the way, from development all the way into ops. If we measure every single step, we can faster figure out if we do the right thing or not, and we can actually stop bad things from happening. Now, I want to tell you now a story that I've been fortunate enough to be introduced to this company. It's actually a Swedish company, and what they built in the early 2000s is it's like a Google for sports club searches in Sweden. So you can actually imagine that website. When you get there, you get a search bar like on Google and a little drop-down box for a city, and you can search for football clubs in Stockholm, for instance, if you want to see where are your football clubs where you want to send your kid to pick up the sport. Started as a two-man project in the early 2000s. It had limited success in the beginning, so the blue line indicating the number of users there on the website. So in early 2015, they said, well, we either stop the project because it was a great idea but didn't really work out, or we expand and try it on a global scale. In their case, they went down the expansion route and said we go from Sweden to all of Europe and also North America. And once they start seeing the expansion, they saw users climbing up, but soon they realized their application, the initial application, doesn't scale and just doesn't work anymore. So what we did, we went to their application. It was a monolithic app. We looked, what you see here is one of the visualizations that Dynatrace also provides, showing the end-to-end, what we call transaction flow, from the web request coming in into the monolithic app, going back to the database. So in April, before they started their marketing campaign to go global, their number one search, which was for football clubs in Stockholm, which returned an amazing amount of 33 clubs in the city of Stockholm, took a half a second, which was good. Unfortunately, after they started the marketing campaign, they saw number of users go up, but also search going through the roof, this hockey stick phenomenon. They could also see by analyzing the performance data that they were totally CPU bound, and because it was a monolithic app that they built in the early stages, it couldn't really scale. So what they did, they went through a third-party provider and said, what can we do to solve the problem? We want to scale up in general, but we also want to go global, and we want to make sure user experience is good for everybody around the world, or Europe and the US in this case. So what this third-party company did, they said, well, very easy. we basically take your backend service and then we build a new front end on top, or we actually extract.
To be honest.
I think there's just a FYI, somebody who is on the phone as a panelist.
Exactly.
Maybe want to mute your phone. That would be nice.
I'm listening to a conference call, by the way, but
let me just.
This is Andy Grabner at the minute. He's presenting with Ranger 4 on DevOps.
Martin, if you can do me a favor and mute your line, that would be great. Unless you want. Sorry. That's okay, but we're agile here. Thanks for listening. So what they suggested is, hey, let's put the let's create a front end, and we can scale this up in the Amazon cloud. So we put it wherever we want to put it to, and we keep the backend logic on your backend data center, and we can just use new technologies like Docker and scale it up and down depending on loads throughout the day. That's a perfect environment. That's what they did. They engaged this third-party company, so extracting the monolith into microservice architecture. On the first day when they went live at 7 o'clock in the morning, this is how the world looked for them. So everything was green in Europe and in the United States. Why? Because I guess Europe was still just getting out of bed, and the United States were just getting too bad. They didn't care about the regions like Australia, not their target market. That's why they didn't care about the red down there. Now, what happened when people actually woke up was a total different picture. All of a sudden, with this new architecture in place, response time went through the roof, bounce rate went up like crazy, people were frustrated. And the fair question that these guys had to this third-party vendor, they said, what went wrong? You told us if we are implementing your change requests, going from monolith to microservice and scaling it up and down in the cloud and in Docker, everything will be fine. Yet nothing is fine, everybody's frustrated. So what went wrong is that there were several mistakes being made. What you see here again, and this is what I like about Dynatrace, having the ability to see every single request end to end. So we extracted one of these requests for, remember, the #1 search that was executed on that system, football clubs in Stockholm, returning 33 search results. We see the end-to-end trace, what actually happens when this was executed at the day when it failed. I'm looking at metrics because we talk about metrics today. So slow response time, also payload. So payload is great to know how much bytes, how many bytes do we actually send back to people that search, because now this is payload that comes from Amazon, so we need to pay Amazon for it. Even though I think 5 kilobytes for a 33 search result is not that bad. However, what was really going on is that they had an architectural violation. So they built this front end new interface that they were running from different Amazon servers around the world, yet what they did, they actually took some existing code from the monolith and ported that over and basically replicated an existing problem that they had in there. In the industry, from a technical term perspective, we call this the N+1 query problem. So in the old code, in the monolithic code, they had one statement, one database query going to the database saying, give me the primary keys of all the sports clubs. A list of 33 came back, and then they made 33 individual database requests to get the details. There was already a problem in the monolith, but still contained within the local environment. Now this problem pattern went global. So one call going to the database, and then for every single search result, one quote-unquote microservice call to the backend, sending 3 kilobytes per call, 99 kilobytes each. Again, data we now need to pay to Amazon. And they also replicated and multiplied the amount of database statements. So this is a project that went terribly wrong and basically brought the system to a halt on that day. Fortunately, they fixed the problem in the end, but obviously it took a couple of days downtime. They fixed it, so they said, well, the way we need to do this, we need to do it right. We need to have one call coming in from the front, one call go into the back, and 3 database queries. That looks much better. Now, the big lesson learned, and I believe this is the magic ingredient, and this is what I believe DevOps has to look like, and how DevOps feedback loops can actually solve this problem and prevent it, is this. What if we do not only measure in production when things fail and then firefight and provide that as a feedback loop? What if we measure everything from dev to ops? What if we measure every single action of every single developer and tester along the way and automatically provide the feedback loops early and therefore prevent things like this? So here is now how the scenario should have come down if they would have used this approach. Let's go back to the monolithic app that they had. Let's assume, which is best practice, to have some tests. Tests for 2 features. The tests are great because we can see how is the functionality of, let's say, the search and a second feature, which is News Alert, another feature on their website. Now, if I would be the company that takes over their project, instead of going through thousands or million lines of codes that it's hard to analyze, why not take a tool like Dynatrace and figure out what is the code actually executing, what is happening behind the scenes when we execute these main use cases, and we would have already seen that there's already a strange problem pattern in the existing code that I'm now taking responsibility for. 35 SQL statements. Dynatrace will automatically flag this as a problem and show you where it's been executed. Now, this is what would have helped, obviously. Now, let's look at production, because I believe monitoring needs to be something that we do in operations, but in pre-prod, but from an operations perspective, we should use it to understand what is going on out there right now. So I'm looking at number of servers. So right now it's a monolithic app, so one server. Usage, how many people are actually using my feature? That's the great business feedback. And if I see only 0.5% use News Alert, that's not good, and only 63% use the search, which is the #1 thing you see on the page, and this is also not good. And maybe it's because of user experience is actually bad, because response time is beyond everything that is acceptable. 5.2 seconds for search and 7.2 for News Alert. So these are the numbers that allow the business people to make a decision and saying, well, we need to do something, we need to fix something. And in my example, this is when they went back to this team and said, please do whatever change you think makes sense. So now the cool thing is, I am this developer, I'm this third-party company. I am ripping apart the monolith into a microservice architecture. I run my tests because I want to make sure that I didn't break anything functionally. But while running the tests, Dynatrace sits in this environment and automatically tells you what is actually going on in your code. And seeing now that I just brought a new problem pattern into my microservice architecture because I have 33 API calls. I have 171 SQL statements now. I'm sending 104 kilobytes over potentially Amazon networks, and I have a huge CPU explosion now. This is all data that allows me, after minutes of checking in the code and running it through my pipeline, that I'm not going to deploy these changes because they will just end up in a production outage. Instead, I'm going back, I fix these things, I run the functional tests again, everything is green. Now Dynatrace also tells me, well, this looks much better now. We have some changes, obviously, from the very early build, 17, because now we have microservice architecture. That's why we have 2 API calls. We have payload more because we send data over a wire. But still, let's deploy this. This is much better. So we can deploy, and then to close the feedback loop, we always need to understand what is the impact. Did we have a positive or a negative impact? And what we can see, if we first focus on search response time is much better, 2.5 seconds. Usage went up to 75%, that's great. But now we're running on 6 Amazon servers, and we know how much Amazon costs us. So then we can make a decision, is the software efficient enough? Or do we need to optimize it? Because otherwise it costs us more to run it than we gain through whatever revenue model we have. And for the second feature, the News Alert, response time has improved to 3.2 seconds. However, it had no impact on the usage. So maybe this is a feature that nobody really likes or needs. So with this, we can make 2 decisions. We need to optimize the features that people like, but we need to optimize it in a way that they become actually even have a better impact. So now 80% usage, even better performance, and we run on less hardware. And for features that nobody needs, we simply take them out. And this is what I believe, if we do this, if we have these feedback loops embedded into our CI/CD process from development all the way into ops, we can make better decisions faster. And to kind of, before I close it out, what if we go back to kind of an overview of how a pipeline looks like, if we have developers sitting on the left side pushing code through, hopefully, a mostly automated pipeline all the way into production, then by looking at all of these metrics, we can allow developer to build better code right from the start, right? Because we already show them what impact and changes their code actually has. We can automatically level up your functional tests, what I showed you earlier, by looking at these metrics and automatically identify architectural and performance regressions, which means we can stop bad builds earlier so that only good builds actually make it to your performance testing phase. So we're not overloading this phase, these teams with builds that are failing anyway with the same reasons. We allow ops, because we do ops monitoring, to keep end users in the environment happy. And to close the feedback loop from did we build the right thing, then we can figure out how do people use our software, feed that back into the development stream and say, whatever change you did yesterday, not a good change because people don't like it. But what you did the day before, that was great. So please innovate on that. So I believe if we do all that, we can build better software, we can reduce lead time, we can stop bad code early, and everything is much better if we hopefully also automate our pipeline. So all the other tools, Helen, that you mentioned and that you are talking about, I think this is in combination the perfect example of how DevOps and feedback loops should be implemented. I hope
Absolutely.
this made sense.
Yeah, totally. And I think it's really important that, when we set out on this journey today about closing the feedback loop, we were mainly focused initially on talking about the value realization. So the bit that you've articulated so well, that we can actually measure the impact of a feature from a business value perspective, so from a revenue perspective and an impact perspective. But actually the other really important thing is about engineering for performance from the very, very start. So having the ability throughout the whole loop to see what impact change is going to happen. So thank you very much, Andreas. That was brilliant. We are coming up to the end of the allocated time for this webcast today. In terms of a call to action and things that you might want to do next, we wanted to keep this webcast to half an hour, but if you want to see this software live in action, see the DevOps loop live in action, then please do let us know. We will be sending you an email following up so you can get in touch with us and let us know if this is something that you would like to do next. And now let's, George, have we got any questions today?
There are 4 questions, but 2 of them are very similar, so I'll pitch those 2 together. So what sort of an overhead does Dynatrace have on the application? And the second question, which I guess you can answer both together, is does Dynatrace sit inside or outside of the application?
So I think this question's for Andreas.
Yeah, happy to answer. So the way we work, we sit in the application. So we have at least the stuff that I showed today in the presentation, we have an agent-based approach. That means we get loaded into your CLR, into your JVM, into your Node.js. So we get loaded into your application and therefore capture information from within, and also are able to trace calls end to end. So one of our, I think what I like the most, and I used to be a developer and architect for a while, is being the ability of tracing an individual call end to end, and that only works if you basically sit within the application. So we sit within the application, and the overhead question, we have between 2 and 3% overhead. That's typically our answer. This is also the answer that our customers give us. Be reminded that we have about 8,000 customers running this. Most of them run this in production, meaning 24/7, always on, every single transaction captured, and they don't see a impact on overhead, or except the 1 to 3% overhead that I mentioned earlier. Of course, you can do a lot of things with all these types of tools that sit in your application, so you can turn things on and off. But I think the general answer is the overhead. We optimize the overhead over the time, so that the majority of our customers, and if you look at our website, I think we have 7 of the top 10 US banks that use us. We have most of the online retailers that we have worldwide, and these use us in high-scale production environments, and they would not use a product like Dynatrace if it would impact their performance.
Excellent, thank you. The next question is, how do you define happy, frustrated, and unhappy customers?
Oh, it's a good one. So we base our definition on the aptex, but we add on top of the aptex. So the aptex is an industry standard that basically says if people interact with an application and let's say it's faster than 4 seconds, they're happy. If it's between 4 and 12 seconds, they are tolerating, and if it's slower than then they're frustrated. We add on top of that, so we look at performance, but we also look at failures. So for instance, if you have a JavaScript error on your browser, if you have a mobile app that is crashing, if you get an HTTP error back, then obviously, even though the page is fast, it makes you frustrated because you cannot get your stuff done. So we factor in performance, failure rate, and we also factor in the environment of the user. So we know based on our product what type of network bandwidth users have. So if they are on a high-speed connection, then we actually lower the thresholds because we assume these people are used to fast browsing. If we see that these users coming on a dial-up on a 2G connection, then we basically raise the bar and basically say, these people are probably used, based on their slow network connectivity, to wait a little longer, and therefore we automatically adjust our thresholds. But the main key components are performance, failure, and the environment that they're running in.
Excellent. Thank you. And the final question, which is for Andy again, sorry, Helen. How easy or difficult is it to deploy?
Well, I think we made it very easy. So what we all learned over the years is that we need to automate as much as possible. So that's why we provide scripts, whether it's Chef, Puppet, Ansible, PowerShell scripts to deploy Dynatrace. We also provide Docker containers. We have integrations into Cloud Foundry, into OpenShift, into OpenStack, into the Google Cloud. So we basically have it's all there for you. The only thing you need to either do, click a checkbox if you're running in one of these PaaS or cloud environments, or you simply use our deployment scripts that we provide, and that deploys the agent. So that's the one library that you need to get on that system. And from that point, you're up and running, and we're collecting data. And we provide two models. So we provide an on-premise model. That means data gets then collected and sent to a Dynatrace instance that is installed in your environment. Very important for most of our financial and healthcare customers that want to manage their own data. So everything is within your data center. Or we also provide a SaaS offering. If you already run in the cloud, if you want to just use it as a service, you can also say, I'm just sending my data to the Dynatrace cloud, and then you use that, you analyze the data in our cloud environment.
Thank you. That's all the questions that we have. Do you have anything else to add, Helen?
No, I think all that remains then is to thank Andreas very much for his time today, and thank all the participants for tuning in, and wish you all the best for the rest of the day.
Thank you very much. As Helen said earlier, we'll be sending out an email follow-up later today, tomorrow morning. The webcast will be posted on the Ranger 4 website and the Ranger 4 YouTube page for you to review or tell your colleagues about, perhaps. So all that remains from me is thank you very much, and hope to see you on the next one.
Thank you, George. Thanks, everybody. Thanks, Andreas.
Thank you.
Bye.
Thank you. Bye.